let's have a tour of the laboratory we were to do on Monday, March 1st. You had the system, the handouts on the biomes and ecosystems, reminding you of the definitions of each of those, and then telling you also that the climate in central Illinois is temperate, humid, and mesic. That's another thing that we'll talk about when we walk out onto the landscape there and look at some things when we go outside for lab. But I want you to also notice that Pennsylvania is in the same three things: temperate, humid, and mesic. So the same climate, essentially, very similar distribution of precipitation, but different biomes. The tallgrass prairies versus deciduous forest. And then gives definitions for what temperate and humid and mesic represent. Also noting that we can have meadow ecosystems within a forest biome, and we can also have forest biomes or ecosystems within grassland biomes. A reminder of what is required for something to be a wetland: the three characteristics: the hydrology, the source of water, the hydric soils, and the vegetation, the hydrophytes. That's going to be important to us as we look at one of our sites today, the soils that I asked you to consider. So, how do we start this one? Well, if you look at our laboratory for the class and go to Biomes and Site Characteristics, you'll see where I wrote in March 1st, our GPS exploration. That's the form that I just showed you. My version is the Word versus the PDF here. I chose the Word document so I can step you through things. The GPS coordinates that you see here for those soils are the ones that I gave you here for lab preparation and needs, I believe it is. No. Switch. Alright, it was in your lab remote via Zoom location, and you've got those locations for where to find those, and you'll notice that I've put for your location map unit MBD. That's going to be 40 degrees and then minus 75. That's where you have here for the manor, and you can also find the Hatboro in that same map unit. We'll look at that. And then the other one, the 40 degrees and minus 76, we're looking for the Duffield soil in those. And remember that they're in normal. You're at 40 degrees and 89 degrees, or negative 89. And so with this system, you remember that the first number is the latitude north to south, and the second number with a negative sign there is the longitude and degrees west. And so we have 40 degrees north and then minus 75 or 75 degrees west. So how then do you find the information on these soils? Well, let's continue. One other thing, I've given you two options, two places you can find information on these soils. The first one is to use the SoilWeb Online browser. That's the same browser that's connected to the app that I had you install on your phones. So if you go to the online soil browser, you get a welcome screen. You can read through that at your leisure. It tells you how to use it. So I'm going to use that and go to my first soil. And my first soil here, location, I'm just going to copy and paste over. So I've got the location of my manor soil. I go to menu on the soil browser, zoom to location, and then I have options. So I can make several different things here. I'm going to enter then my latitude and longitude, and you'll see that I've already got it in the same format that it wants it. So we're going to put these in here, and then click go. Now I've got a position here. It says that I'm in this park. If you want to see where you are in a little greater detail, you can always back out. And this particular site is in the Wissahickon Park in Philadelphia. It's the largest urban park in the country. And so once you've got this one, click in this area that says MBD. Now you'll notice that the Manor soil is listed there, as is the Hatboro. So as you look through these, you're going to work through these soils, and if you click on Manor, it gives you a typical, what a profile would look like. And then as you scroll down, it's got something here that asks about soil taxonomy. Now I don't think that I had you asked you to put in the soil taxonomy here. I did too. Soil taxonomy, there it is. So if I click on soil taxonomy, I get the family level of classification, and that's exactly what I've asked you to capture there. So if I copy and paste on my soil taxonomy, I'm going to paste just my no format. There we see coarse loamy, micaceous, mesic, typic distru depths. Now notice this is the subgroup level of classification, as I mentioned in class this morning. Each of those words is capitalized. So the great group name is capitalized, distru depths, and the subgroup name, typic distru depths, those are both capitalized. And then the characteristics of these characteristics for the family name is that those are lowercase letters. Now this is one of those that you can't just choose which ones you want to capitalize and which ones you don't, because this is our standard. It's the way, our protocol that we use to write these out. So coarse loamy, that tells me something about the texture classes. Micaceous tells me about the minerals, and then mesic tells me about that temperature regime that we noted already. The UD in here tells me that I'm in that humid environment. So I've got a lot of information about that soil, most of which you have to learn more in order to interpret. Now I've got some pictures that I'm going to post later about this micaceous soil. Micas are thin, flake-like particles, and they also catch light and glitter. Might have been the inspiration for using glitter, because if you get it on your hands, it glitters. And so I was texturing soils, breaking up the aggregates to put into my tubes there that I'm going to use for my microbe stuff. And I looked at my hands and they glittered. I'm trying to get some good images of that for you. But that's what the micaceous tells me about the mineralogy of that soil. So if we go and look for more information, what can I learn here? Well, that tells me my soil series. That's where I had my levels of classification. Again, you notice that the order Inceptisol is capitalized, the suborder U depths are capitalized, the great group distru depths, and the subgroup typic distru depths. They're all capitalized. And the cool thing about taxonomy is if you have any of these lower levels of classification, you know what it is at every higher level. So at family, you see typic distru depths in there. Well, that's the subgroup. When you go from subgroup to great group, you say it keeps distru depths. When you go from great group to suborder, you've got U depths that you can see. And when you go to U depths to inceptisols, what you see is this root, EPT. And we have that same root in inceptisols, EPT. So that's one of the really cool things about soil taxonomy, is that you know one level of classification, you know every higher level of classification until you get to series. And series doesn't tell you anything. Manner. I don't know anything about that soil when all I know is the series name. What else might I be asked to find? Landscape position. I don't see anything on landscape position. These are classification system. Well, it tells me this one is on an 8 to 25% slope, but it doesn't tell me where I might find that. What kind of landscape positions I'll find that. And just for my own information, I'm going to put in here that this was, again, the MBD, and that it's on an 8 to 25% slope. And it also tells me that it's extremely stony loam. Now, you know what a loam is, but the extremely stony part, that's one of those modifiers, and stones are large. So we were talking in lab that we start with gravels, we go up to cobbles, and then you get to stones. And stones start at 25 centimeters or 10 inches and go up to about a meter or 3 feet. That's how big stones are. So there's a lot of big rocks in there. I'm going to change my style here just a minute, my spacing. Oh, why does it do this? I just needed the space, and if this doesn't work this time, I'm going to quit and go on and try something else. There we go. All right. So I don't know from this one what my landscape position is, so let's see what else we might know about this one as we find information. Well, we've got something that asks about hydric soils. Well, hydric is one of those hydraulic properties potentially, so let's look. So we learned about erosion groups. We'll figure that out later in this unit. Runoff, it tells you that. It is a well-drained soil. We'll talk a little bit about what that means. It is not hydric. So you've got a hydric rating there. So in this case, it's not hydric. So we got no, not hydric. We still don't know our landscape position, so we'll come back on that one. Ecosystem, see if we've got something on the native. Got something on forest productivity. What does it tell me on this one? There's a lot of things in there. Lost it. There's a lot of things in there. And the forest productivity, that's one of those interpretations. So what plants are there, and how much could they produce in terms of lumber if you were going to grow them. And you'll notice only a few of those have forest productivity. Most of those are native plants that they're not used for forested or for lumber. What else do we have here? Suitability ratings. We can pick some suitability ratings that you might find in making information or finding more information about this soil. But before we go on, I'm going to show you the other tool that we'll use to find information, and that's the official series descriptions. So if I go to the official series descriptions, in this case I've got something where I just put in the name of this soil. I'm talking about manor. Manor is the series name, and so I tell it I want to know about the manor, and I just clicked enter, and here we go. So what else do I know about this soil? It tells me there, I can see I've also got that family name for the taxonomy. It tells me I'm in a typical pedon. That would be in a wooded lawn, a wooded area. And then notice that we have the profile description. We looked at those monoliths in the lab and started trying to work on profile descriptions. So here we have the profile description for this one. You see that we're going to have depth of that horizon, the color of that horizon, the structure, and friable is one that we couldn't do, but that's another characteristic of structure. We've got something about roots and pores, and then those mica flakes, because this is a micaceous soil. And then you've got some schist channers. Channers are flattened and sharpened rocks, if you will, and it's an acid soil, and we talked about boundaries, clear and wavy. Now you've got the other characteristics. We have two BW horizons, so BD1, BW2, and we got three C horizons. That's our parent material, so C1, C2, and C3, actually 4, C4. Well, none of those things we've asked for yet over here on this side, so let's see what else we need. We need to know something about its landscape position, where we're going to find it, native vegetation. So let's keep reading and see what else we can find. We can find information about these horizons and the depth of those horizons, depth to a water table, those rock fragments, content of mica. It tells us the common thicknesses and range of those that have been defined for the original that profiles. And then we come in here and we find that we find this soil on uplands, in summit, shoulder, and back slopes. So that's our profile position, our landscape position. We don't know exactly where this particular soil is located, although I'll tell you it's probably on a back slope, and if you look at where that point was placed. So what I've got is I've got an upland. I'm going to put that in here, and it's an upland, and I'm going to find it on summits, meaning at the top of the hill, on shoulders, meaning those convex parts of the slope, and the back slope, that's the somewhat planar slope that's going down the hill. Now, what else can we find over here? Parent material is weathered from micaceous schists. We knew that one. I talked to you about the mica and the micaceous. We saw that in its field, in its family level name down here, micaceous. That's the rocks that it came from. Schist is a volcanic rock of some sort. The slopes can be very steep, 0 to 65. I'm currently in Philadelphia, so we're not that far from the ocean, so we're at relatively low elevation on the low end of these, but it can also be found up in the mountains, so a little bit higher. The mountains on this coast in this direction are much lower than those in the west. It tells you that there's some associated soils. It tells us about our drainage class, that this particular soil doesn't flood or pond. It doesn't have much runoff, although well, negligible to high. It can have all sorts of different variation on the runoff. Doesn't have shrink swell potential. Wait. Dominant vegetation, use in vegetation. So it tells me that this soil, when I'm looking at the dominant vegetation, we know it didn't start in cropland. So woodland is the ecosystem. It's a forested ecosystem. Since we know that cropland is not a biome. So we had a forested ecosystem. And currently, then if we talk about that, well, in that one, when you looked at the picture, it was still in a forest. What kind of species would you expect to find in this one? And so it says where it's wooded, you're going to have all these different species. So again, I'm just going to copy and paste that. The dominant species I'm going to expect to find in that landscape, in that forested biome. And my current use here is in cropland. No, wait, this one is a park. One of those others is a cropland, so I'm getting myself ahead of. So this one's in a park, so it's used for aesthetics, for wildlife, urban green spaces, whatever you want to. It's that. Urban green spaces are really important for human emotional health, though we only recently discovered that. And let's see, we got everything. We've got, then there's something else I put on here just for observations. Now, at this point, I'd hope to be able to take you out there and give you a visual tour. But that we weren't able to do that, so I'm just going to ask you to look at let's close some of these and give you a chance. So what are you looking at and what are you seeing here? Well, you're on this hill slope. You can see that it's vegetated, and you can see as you look down here that there's a stream at the bottom of the hill. So this one is on that back slope position. Now, I would try and open Google Earth Pro for you, but it's messed up for me right now and it won't open on the screen. Last time I opened it, I was using 2 monitors, and even though I don't have 2 monitors, it's trying to open up on the other monitor. But that is your quick tour of how you complete these. So I might put wooded, back slope, and then stream at bottom, something like that. Now, if you could go to Google Earth, you could see there. Maybe I can add a Topo Map. And so my Topo Map, I'm at 200 here and 260 there. So you can see that you're going downhill. When we get down at the bottom, I think that says 80. So you're dropping some elevation pretty quickly there. 60, 50, 40, 30, 20, 10, 200, 90, 80, 70, 60, 50, 40, 30, 20, 10. So 90, yeah, that 80 at the bottom of that hill. So pretty steep. So those are some things that you could look at. Again, if you went into Google Earth, you could probably even pull it up as and look at it in a 3D map, potentially. But that's all you need to be able to finish this one up. So have a great afternoon or morning or whenever you're choosing to do this.